Let's have a quick look at the capabilities of reflection in .NET Core. So what is reflection? In software engineering, the ability to examine and modify either the structure or the behavior of a program at runtime is reflection. So you can both change the value of properties and fields, which is the structure of a given type. And also you can change the behavior. For example, you can call the methods and send different parameters to methods at runtime. In .NET Core, there are two primary assemblies, which are system.reflection and system.type. With these two assemblies, you can get the metadata of types and objects. By types, we refer to classes, enums, and interfaces. And once you have the details of types, if possible, you can create instances. By saying if possible, it means that, for example, you cannot create an instance of an interface, but you can create an instance of a class. So if you get the metadata of a class, then you will be able to create an instance of it at runtime. There is something called Common Language Runtime Loader in .NET Core, which manages the application domains. Application domains specifies the scope of a loaded assembly and its memory layout. And that is basically because you want to avoid the conflicts of having different assemblies loaded into memory. When you load an application into memory by running it, the application will have one or more assemblies loaded, and each assembly will come with one or more namespaces, and each namespace will come with types. As I said, types can be classes, enums, and interfaces. Every type has some members. Members refer to fields, properties, and methods. And by having the information about types and members, what you can do is that you can get the details of each type. And by having the type information, you can create the instances of a type. Also, you can get the information about members. You can invoke methods at runtime. And you can change the value of a member. For example, if you have a property called age, you can change its value at runtime. So let's start with the main class in reflection, which is the assembly class. The assembly class gives us information about an assembly. An assembly is the building block of a common language runtime application. Assemblies are built to be reusable, so you can put classes and helper classes and models and everything in an assembly and reuse it across multiple types of applications. Assemblies are versionable, so you can have different versions of assemblies and use different versions at the same time. And assemblies are supposed to be self-describing. They come with metadata so that when an application loads an assembly, they can get plenty of information about the assembly. Things that you can do with the assembly class is that you can get the current executing assembly, which means that within a code, you can understand which assembly is running that code or where that code is located. With having the class and a type, you can create instances of that using the assembly class. You can invoke the method of a given class using the assembly class. And also you can get some metadata such as name or file name or version number of the assembly. So let's go to Visual Studio and see what we can do with the assembly class. So now I have created a console application with .NET Core and CSharp in Visual Studio. In order to have access to the assembly class, we need to have a reference to system.reflection assembly. So by doing this, we will be able to have access to some assembly information. I will do a console clear to clear the screen. So the assembly class has some static methods as well as non-static attributes and methods. When you use the static methods and properties of the assembly class, normally they return an instance of assembly class. For example, if I just type assembly, you will see that there are a bunch of methods and attributes in here. So for example, getAssembly method will tell us that which assembly includes the type that we provide in here. Whatever assembly that is returned, that is a loaded assembly. It's not like an assembly in a DLL file. So we need to pass a type to it. For example, we can say type of, and our class is program. So we can pass type of program, and let's put this in var assembly info is equal to, assembly, get assembly. Now I put a breakpoint and run the application. So if I just step over this line and I hover the mouse, as you see, I have an object of assembly here with some properties that we can go back and see. So get assembly type of any class or type will tell us which loaded assembly includes this type. If you have a class with the same name in different assemblies, you will have to use the full names, which is the namespace dot class name. Let's see the other methods as well. So we have, for example, get calling assembly. Get calling assembly will tell us that which assembly has called the current method. Again, I put a breakpoint in here and we just step over this. Again, we get an assembly information in here. Again, let's have a look at some other methods. For example, we have get executing assembly. Get executing assembly is the main assembly of a program. So if you have a website or Windows application or WPF application, whatever you have created, it always has a main assembly that has an entry point and everything starts there. For example, in the console application, you always have a program class and a static method called main, and that is your entry point. So the namespace is whatever namespace that includes the class program and the main method. Again, I run the application. Again, if we just skip over this, we have an assembly, which if I open it, the assembly is reflection.NET Core. Reflection.NET Core is just the name I have given to my project. So the project name is reflection.NET Core, and if I go to properties, the assembly name is also reflection.NET Core, as you see in here. So that's why we get that name. You also can load an assembly with a DLL name. So if somebody has created an assembly and you have the DLL file, you can use a load file and then just pass the file path and name in a string. For example, you can say C, this is a random path, temp, for example, my assembly.dll. We will work with this actually in the upcoming lectures. We will see that how we can load assemblies and do things with them. So that's one way of loading assemblies. And then once you have the assemblies, what you can do with it is get the types and get the modules and everything and do stuff with it. We will see these things in the other lectures. Another way of getting assembly information is using the type. For example, we have a class called program in here. So we can say type of program. Type of will return type. So I can say that type, my type is type of program. So type of always returns type. Type is a class. So let's just pick its definition. So type is a class which is IReflect and is inherited from member info. What it does is that it can give you information about attributes, about names. It tells you if it's an interface and other things. Also, if we go inside member info, you can get some information using the member info as well. For example, name and reflected type and declarating type and everything that we will see later. Also, as you know, normally everything that is inherited from object has equals. So in here, equals is overwritten as well, and also get hash code. And if there is any operator overload, it is happening in the member info class. So making things short, if you use type of, you will get a type. When you get a type, you can do things with it. For example, if you want to see which assembly owns the program type, you can use my type assembly. This is, so this line, so these two lines are equal to saying assembly get assembly of type of program. Basically, these two will give you the same assembly. Either you get the type and then find the assembly, or you just directly go with the static method of get assembly, but then you have to pass the type. Also with type, when you get the type, you will have access to methods, you can have access to properties, to fields and things like that. So a type with capital T will give you information about a type. For example, it tells you if it's enum, if it's a class, if it's an interface, and things like that. We will see these later. So the type class, which is in system assembly, will give us a lot of information about a type. And a type, as I said before, can be a class, can be an enum, or can be an interface. So I stop recording here. I'll give you some coding practice and then we continue with the course. Now that we know how to access type information as well as assembly information, let's see how we can create an instance of a type. So you know that in order to have access to type information and assembly information, we use type of keyword to have the type information. Also, we can get the assembly from type, or we can just use the get assembly method of the assembly class. With having an instance of assembly, which means that we cannot use the static methods of assembly class, we need an instance of assembly class. You can create a type by having the type in your code. So I just remove this line because type.assembly basically does the same thing. It gives us the assembly information, and in order to get an instance, we can say var instance is equal to my type assembly dot, and then it has a method called create instance. And as you see, you will pass a type name in here. In this case, the type name that you will pass is the fully qualified type name, which means it should be namespace dot class name, for example reflection.net core dot program. And you can also specify that you want to ignore casing in a type name. So if I type true, then casing won't be a problem. So if I hover the mouse on create instance, you will see that the return type is object, which means that you will have to cast it to the type that you want to create. So let's run the code and see what we get. So I step over, an instance, as you see, is reflection.net.program. There is also another way of creating a type, which is if you have your type not loaded into memory and it's in an assembly, what you can do is to use the assembly name and then type name format. For example, it can be, if your assembly name on the disk is assembly DLL, you can say assembly.dll, comma, and then your type name, which includes the namespace name and class name. We will see this later. We are going to do some project with this. Also, another way of creating an instance is using a class called activator. So let's say instance 2 is activator dot create instance. So activator create instance accepts either a type, for example, you can say type of program, which is your class or type that you want to create an instance of. If you do this, so if I hover the mouse, create instance returns object, which means that you will have to cast again. Another way of creating an instance of a type is use the activator, but then use the generic version of create instance. So if I say create instance of program, then there won't be a need to cast at the end. Also, if you have your type inside a DLL and it's not loaded into memory already, you can use create instance of the activator class, but then as you see, it has an overload which accepts assembly name and type name. For example, again, you can say my assembly.dll, and then your type name should be fully qualified type name, for example, reflection.net core.program. But then if you do this, then you will not get an object. As you see, you will get object handle. So if we have a look at the properties, there will be unwrap property, which gives us the object, and you can cast it in order to get the instance. So instance 4 is basically instance handle, and then you will have, let's do it this way, var instance 4 is equal to instance handle unwrap, and then you cast unwrap to program. That's how you have access to the instance. How I use this is that if my type is not already loaded into memory and it's residing inside a DLL, I use activator.create instance rather than the assembly class and then create instance, because it seems cleaner to me. It doesn't mix up the type that we have loaded into memory with the type that we haven't loaded into memory. So this is how you will create an instance of a class. If your class is implementing an interface, you can also cast to that interface. But if you want to pass your type to create instance, you cannot pass the interface to the create instance method, because you cannot create an instance of an interface. You have to create an instance of a class, and then if you want to access the specific attributes of a given interface, then you can cast it to the interface. Using reflection, you can get information about members of a type, specifically a class. Members can include constructors, which if you get the information about constructors, you will get an object of type constructor info. Also, events are members, and when we get information about events, we get an object of type event info. Fields are members, and they are described by field info. Methods, which then we get method info for them, are members as well. And nested types and properties are member info as well. Nested types are described with member info, and properties are described by property info. When do we use members? We use members and member info when we don't really have a specific knowledge about what properties exist or what method exists. We get the members, and then checking their types, we figure out what we are dealing with. So let's go to Visual Studio and write some C# code to understand this better. So let's create a class and then work with its members. I want to create a class, so let's say public class, and let's call this car or vehicle, whatever that makes sense to you. And let's add a property. So for example, we can say double public double and then engine size, and just leave it as it is. And also we can say public void start to start the car, and it does nothing. Also, if you want, you can add fields and you can add other types of members. Now, in order to work with this type, we need a type of. So we can say var car type is type of car. And then in order to get the list of members, we can call car type dot get members. So as you see, you can call get members without parameters. However, you can pass a binding flags parameters as well. Binding flag is an enum, and with that you can filter that what kind of members you want to get. For example, you can pass binding flags public. That will only give you the public members. You can also say or binding flags dot static. That will return static members as well. So in order to work with the members, we just loop over it. So we can say for each member in members, and what things you can do if you just type member, you can see that it has member type. So we can say, for example, if member dot member type is equal to member type field or member type method or member type property, we can say property. For example, we can say member as property info, and then you will get some extra attributes. For example, can read. That means that if your property has a getter, can write. If your property has a setter, and things like that. We will work with property info class later. Likewise, you can convert this to method info, and you can say that method info, and then you work with the attributes of method info class. We will see it in the next lecture. So for now, let's do this, and let's just work with the generic attributes of member info. So we can say let's see what we have. So we can have member type, which gives us the type, and then you can have name, which is the name of the member, and those are the most important ones. So let's write them to the output console, write line, and then we can say member, and then member name is of type member type. So before executing our code, I will remove the binding flags because I want to get all the possible members that a class can have. Okay, so in the output we say, so if you remember, we added property and method, one property and method, but we have plenty of members. So from the top you will see that get underline engine size is of type method. That means that the getter is a member and the setter of a property is a member as well. Start is of type method, obviously, because we added it. You see that toString is there as well, because every class that gets inherited from object class obviously has toString, although we didn't have it in the method. It's here, equals as well, get hashcode as well, get type as well. .ctor is your constructor, because we said that constructors are a type of method. Member info as well, and engine size is the property. So using member info, you can have access to almost every part of a class. In the next lectures, we will see how we can work with properties, fields, and methods, and then we will write a code to do like a practical work with reflection. So in this lecture, we want to see how we can work with the methods of a given type. So I'm going to create a new class. We will call it public class. Let's call it person. And for now, person will have a method called write. Let's say public void write and string message. Actually, instead of write, maybe we say. It's more relevant to person. And then we can say console write line message. Now, if I want to get the list of methods of this class, I need to get this as a type. So we can say var person type is equal to type of person. So we know this. And then from this person type, you can call the get methods method. Get methods will return a list or a collection, in fact an array of method info objects. So let's call this var method infos. And obviously either you can loop over through this, or we can just do dot first or default to get the only existing method, which is this one, say. So let's call this method info instead of method infos, because there will be only one. Now things we can do with this method info is that you can get its return type in case there is any return type. Our method is void, so it will have no return type. It will return null if you use this. Otherwise, it will give you a type, and you can compare it with type of. For example, you can say return type equal to type of, for example, int, to see if the return type is int. You can use a statement like this. Also, there will be information inherited from member info, such as is abstract, is private, is public, and things like that. One thing you can do with the method is that you can invoke the method. To invoke the method, you need an instance of this class first. So we can do it this way. We can say var instance is activator, create instance, type of person. This is gonna create an instance, and we can pass that instance to this, and then you can pass an array of parameters. For example, for say, we can say hello, and I removed this so we won't mix them up. Clean up the code, and you have to pass an array. So let's say new, and let's run this and see what happens. So as you see, it says hello. So we invoked that method using reflection. in that object. You always don't create the instance yourself, so you don't know what the method is. That's why we don't call the method on the instance directly. And also you can do things such as getting name, such as name, and everything that you can do with the method. The most important thing is that you can basically just invoke a method using method info. So there are two more types that we need to learn. One of them is field info, which is information about fields, and the other one is property info, which is information about properties. So let's create a new class. Let's say we have a class called public class, and let's call it personnel. This class has a field. Let's call it public read-only int and then personnel ID, and we just leave it as it is. And then let's say that if you want to create an instance of personnel, we need to pass the personnel ID. So we turn the default constructor to private, and then we will create a public one, and we will say that you need personnel ID to be passed, and in here personnel ID is equal to personnel ID. And also let's add a property. For example, we can say public and let's say int salary. Let's say it has getter and setter, and I clean up the code so you can read it easily. Okay, now in order to get the field information, we need to get an array of field info. So let's say var field infos is equal to, and then you get the field info here, but then before that you need the type. So we can say var personnel type is type of personnel, and fields will be personnel type get fields. If you have a specific field that you want to get its information, you will say get field and then you pass the field name. But if you say get fields, you get all fields. And again, you can pass binding flags. For example, we can say binding flag and say public if you want to get public ones. Or you can say non-public to get non-public methods. For now, we don't pass anything. And actually, I will change this personal ID to private as well. So let's write the field info on the screen. So we can say for each field infos, and we call it field info. So information that we can get from field info is, for example, is private. We can convert it to a string. For example, we can say var is private is equal to yes if it is a private, no if it's not a private field. Also, we can say var is public. We can do the same thing. We can say is public. If it is, then the string representation will be yes, otherwise no. You can also have is static, which will be known by is static property. Again, we convert it to string representation, and you can do quite a few things. You can also grab the name, so we can write it on the screen. We can say write console write line, and let's generate a string such as field and then field info name, private is private, and public is public. We can do the same thing with static is static, and that's it. I again clean up the code. So let's run this and see what happens. As you see, we couldn't get any field information, and I will show you why. Let's go back to Visual Studio. So because our field is private, we can't just get it with making a call to get fields. We need to pass some binding flags. So you need to pass binding flag, and because the field is private, we have to say that's non-public. Also, when you call get fields, and later as we will see, when you call get properties, you have to tell reflection whether the field or property is static or it's an instance. binding flags dot instance. So I will run the application again. So as you see, now we managed to fetch some field information. The first one is field personnel ID, private yes, public no, static no. And we have another field. Although we created only one field, as you see, we managed to fetch two fields. And the second field, as you see, is salary underline backing field. So every time you create a property in behind the scene, .NET creates a backing field for you, which is private yes, public no, and static no. You won't see this backing field, but there is a field in the background. Now let's get some property information. So to get the properties, we can again get the properties from this type, personal type. So let's say var props is equal to field, personnel type, get properties. And if you have one property that you want to get information about, you can just say get property and pass the property name to it. So let's emit some information about these properties on the screen. Again, I can say for each props, and let's call it prop. So what things we can get? We can get prop, and you would have can read, which tells you if you have a getter, can write if you have a setter, and also you can get the method of the get accessor as a method info, and likewise you can get the setter of the property as a method info, and you can also get value and set value. So let's first emit some information on the screen. We can say console write line, and let's say property and prop dot name can read, prop can read, and likewise can write, can write. I just scroll a bit so you can see, and I clean up the code. Let's run the code and see what happens. So we have the field information that we just saw, and then as you see, now we have 3 lines about one property that we had. So the property name is salary, can read, true, because it did have a getter, and can write, true, because we did add a setter for the property. So now I remove these 3 lines that we added, and we do something else. So let's find the one property, the salary property that we had. So let's say for now var personnel is new personnel, and we have to pass salary. Let's say 10. And then we can write this salary on the screen. So we can say write line salary is personnel salary. Now let's get the information of the salary property. So we can say var salary property is equal to, the type was personnel type, dot get property, and we say salary. And what we can do with this, salary prop dot set value. In order to set the value of a property, you need an instance of that object first, so that is personnel, and then you can set the value, let's say 99. Now let's print the salary out. I just reuse the line of code that I had, and let's run this. So as you see at the bottom, at the beginning, it says salary is 0 because we didn't set the salary. We only passed personal ID to the constructor. We set the value with setValue method to 99, and as you see, we have 99 as the value. We can also get and set the value of a property using the get or set method. For example, to read the value of salary property, we can do this. We can say var salary is equal to salary prop, which is the property, dot get method. That gives you the getter of that property, and you can invoke this method because it's method info, and you need an object which is personnel, and also you need to pass parameters to invoke, but because this is a getter, we just pass null. And I just do this with a breakpoint, so we won't have to go to another window. So if I skip over this and I hover the mouse, as you see, salary is 99. which means that we can even get or set the value of properties using invoke. The last thing I want to show you is that how we can create an instance of this personal class using reflection and pass a parameter to its constructor, because it didn't have a public constructor without any parameters, because we made the parameterless constructor, which is default, we made it private. So we can call this, we have to call this constructor, and this constructor expects a personal ID. As you see, we are passing it in here. So if we don't want to use new and we want to use reflection, as you know, we have to use activator. Activator, as you know, has a method called create instance. If you want to pass parameters to the constructor, you cannot use the generic version of create instance method, because as you see, it has no parameters. You will have to use the non-generic version of it. And as you know, to create an instance of a type, we pass type with type of the class, which is personnel. Now, in order to pass parameters to a constructor, we can just put the value in here. For example, we can say 10. If you have more parameters, you just put comma and then you add more parameters. And because personnel is not typed now, it will be just an object. You need to cast it to personnel. And as you see, our code has no error now because personnel is a personnel. And if I put a breakpoint and run the code, you will see that we can create an instance without any problems. So I skip over this. And if I hover the mouse, you will see that we have personnel and personal ID is set to 10, which is great. Okay, so we go to next topic. And in next topic, we want to work on an interesting project. In this lecture, we want to see how we can use reflection to find out if a type or a member of a type is decorated by a given attribute. You can use this for validation and for doing things on types dynamically. So I will show you in the code. Imagine that we have this personal class that we created in the previous topic, and we want to add a new property to personnel class. I'm going to call it, say, name. Every personnel must have a name. So we have to say that this property is required. So we just decorate it with required attribute. Although we type required here, that's actually required attribute. So actually, let me just show you. If I just say peak definition, you will see that this class is called required attribute, although we say required because it's attribute. We can also create a new attribute. So let's do this. Let's create a new class and call it, for example, role or something like this. So let's say public class, and let's call it personnel role attribute, and this is inherited from attribute class. And let's add a property to it. For example, is manager. So we can say prop bool is manager, something like this. So we use personnel attribute on the class because a class of personnel represents a personnel. So we can say personnel role, and we can say is manager false. Now we have one attribute applied on the class and one attribute applied on property name. Let's see how we can see if the object of type personnel is a manager and if the name has a value. So just like always, we start with getting the type. So we can say var personnel type is equal to type of personnel. To see if there is a role on this type, there are different ways. So to get the list of all attributes applied to this class, we can say var all attributes is equal to the type and then get custom attributes. You need to pass a Boolean value to this, which says that do you want to check the attributes on only this class or to all the base classes as well. So if personnel class was inherited from another class called, say, employee, and employee was inherited from a class called person, and then you would apply any attributes on, for example, employee, then if you will pass true in here, you could get that attribute as well. If you pass false, you only get the attribute that is directly applied on personnel. And if you want to get a specific attribute, we can say var role attribute or attrib is equal to the type, and then you can use get custom attribute rather than attributes. And for this, we pass a type, for example, type of personnel role attribute. That would give you the type, and we can work with that type. For example, we can cast it. For example, we can say var, let's say console write line, the personnel is a manager, and then let's just type in here role attribute, but this doesn't have the property that we defined, which is manager, so we need to cast it. So we can do it in here. Let me break the line so you can see. So we can do it in here. We can say as personnel role attribute, and by doing that in here we can say role attribute is manager. You just have to check and make sure that role attribute is not null. So let's run this code and see what we get. So as you see, it says the personnel is a manager, false, and it is false because we did pass false in here. Now to see if the name property has a value, you need to get the property as a property info first and then work with it. So we can say var name property is equal to our type, which is personal type, and then get property. You cannot say get member. You cannot do things with attributes when you use get member. You have to use get property, get method, or get field, and things like this. So we get property, and that is name, and you want the required attribute, so we can say required attribute is equal to name property get custom attribute. So you can again use get custom attributes to get all attributes, but there is also a generic method get custom attribute. So if you use this, you can pass the type, which is required attribute, and then there won't be a need for casting, which is better. But you will have to check to make sure required attribute isn't null anyway. For example, we can say if required attribute is not null, then that is when we need to check to see if there is a value for required attribute. One of the things you can do with required attribute is that you can pass error message right in here. For example, we can say name is required, and then we can check this value if the attribute exists. So if the attribute exists, you can say console write line, and then you can use, for example, it's error message attribute. We can say required attribute error message, but you only do this if you have an object and the object doesn't have a value for its field name. And you can do the same thing for methods. You can do the same thing for everything that can take an attribute, and you can use attributes to do a lot of cool things. For example, with custom attributes, as you see, you can apply roles, you can apply conditions. So in this lecture, we want to put everything that we have learned together and create a small calculator program that they get plugged into the calculator and being used. So the calculator itself doesn't have any capability of calculating anything. Every calculation will be a plugin that we plug into the program. So let's start. So I'm gonna create a new project, and it's gonna be just a console application for now. So we say console app with .NET Core, and I call this calculator, and click on create. That's it. So when you want to create plugins, you have to have a kind of class library or something like a NuGet package or something that you can share with everyone who wants to create a plugin for you. And that class library should include one or more interfaces that everybody has to implement. That will make sure that everybody is following the same standards and same signature and everything. So let's call this common. And class 1, I just changed this to, let's say, iCalculator. And this one will be interface, not a class, and iCalculator. So every calculator should have a name. So I call this public string, and let's call it a name, and it doesn't need setter, it just is fine with only getter. And also they should be able to calculate something, so this cannot be public, it's interface. So we can also say double and then calculate double x and double y. I clean up the code. That's it. So whoever wants to implement a plugin, they have to implement this interface. Now let's implement a plugin. So I'm going to add this DLL to the same solution, but technically anybody can create a DLL using this interface. So I will create the DLL or class library in this solution, but I'm not going to make any reference from this calculator to that DLL. So let's say add and then another class library. I'm gonna call this, for example, add plugin. So add plugin must have a reference to common, because as I said, we give the common class library to people. So we call this add, and that should implement iCalculator. So every time you implement iCalculator, you have to provide a name, and that's why it doesn't have a setter, so it can be just simple as add. And for the calculate, because this is add, we return x plus y. So it's a very simple operation, as you see. And then you can implement subtract and multiply and a lot of other things. So as I said, now we have our plugin ready. I just rebuild this and we go to where it is located. We go to bin debug.NET Core 3, and we need to pick up this add plugin and put it somewhere. You can put it in the bin folder of the main application, or we can just go to a folder and put every plugin in a given folder. For example, if I create a folder called plugin, I can just copy all the DLL files in the plugin folder and load everything from this folder. Now we want to go to our application and implement code to load all plugins and use them. So we go to program. I'm going to write everything here. So let's start with loading everything. So we want to load all plugins, and we know that every plugin is going to implement iCalculator. To have iCalculator, we need a reference to common, but we don't add any reference to any plugin. So I'm going to have a collection of plugins. I will create a dictionary because every time we load one of the plugins, I want to give them an index so that user can choose which one they want to use. So let's say dictionary of int and iCalculator. We call them plugins and we create it so we can use it. And let's get all the plugins. We can say const string plugin folder, and then in my system it is C plugin. Okay, now we need to get all the DLLs in that folder. So we can say var all files is directory dot get files, and then we pass plugin folder. Then we want to go through all these files. We can do a for each all files, file in all files. And now we need to load every assembly file. So we can say var asm or assembly is, we need to use the assembly class, which is in system.reflection, and we have to use load file. If you want to load a DLL from file, you just use load file and we pass the file. So now we have the assembly. Then we want to get all the classes in this assembly. So we can say var types is asm get types. This gives us all types, but we don't need all types because your class library may include some other classes that they don't implement iCalculator interface. So we don't want all. We want only the ones that iCalculator is implemented by them. To do that, we can do where or first or default. Because I know that every plugin will implement only one operation, I just use first or default. And the condition will be that we have to make sure that iCalculator is implemented. So we can say type of iCalculator, and there is a method called is assignable from, and then we pass the type to it. So if the type that you have, which is your class, if you pass it to is assignable of type of your interface, and it returns true, that means that this X, which is your class, your type, implements iCalculator. And so we change the types to class type, something like this. So if class type is not null, because if no class is implementing that interface, then we shouldn't do anything. Now we can create an instance of that class. So we can say var class instance is, now we create an instance of that class using create instance, and what we need to pass to it is the type, and we need to cast this to iCalculator because we know that it implements iCalculator, so it's safe to cast it. So now we can add it to our dictionary. As I said, we only need a counters because we want to have an index in the dictionary, so we can say var index is 0. So we can say every time you manage to get an instance, we say index plus plus. So we add to index, and then we can say plugins, which is the dictionary, add index and class instance. So now we add all the instances that we have with an index. So everything is loaded in here. Now what should we do? We should start basically doing the calculator job. So let's say console clear, that clears the screen, and I'm gonna say console write line or write enter value number 1, and I will have var value 1 is equal to, I'm going to write an unsafe code, but this is only because I need to make things simple. So I will say int parse and then console read line. So I may enter ABC, and then that int parse will raise error, but I'm just making things very simple. So we can say the same thing. We can say console write enter value number 2, and we do the same thing for another value. Var value 2 is int.parse console read line. Okay, so we have 2 values now. Then we have to say choose an option. So we can say console write line choose an option for each plugin in plugins. Then we write them here, console write line. So we have plugin.index, which is the key, plugin.key, and put a parenthesis here, and after this we can say plugin.value, and we know that value is of type iCalculator, so it does have a name attribute. So now we need to get the values, so we can say var option is console read line. We can again do int parse, although again it's not the safest, and you can put checks to make sure that people choose the right option. So if you have option from 1 to 3 and they choose 5, you can say no, this is not valid, and repeat. So we just don't do that because we want to make it very simple. So now that you have the option, you can find var instance is equal to plugins, which is a dictionary of everything you have, and you want which one you want, whatever option the user has chosen, and you can now do console write line, and let's say the result is instance calculate and value 1 and value 2, and we just do a read key so we can see the screen. So I built this code and it has no errors, so we run the code. So value 1 I say 2, value 2, I call it 9, so we should get 11, right? So choose an option 1, the result is 11. So we managed to plug the add functionality. Now what I'm going to do is that I'm going to add another plugin using another console application. So we call this subtract plugin this time. Subtract plugin must have access to common, so we need to add a dependency to common, and this class, whatever you call it, it should implement iCalculator. So name will be subtract, and what it does is that it returns x minus y. Clean up the code. So all we need to do now, see how easy it is. All we need to do is to build this plugin. We go to where the plugin is located in bin debug, and I just need to copy this subtract plugin to my plugin folder. So where was it? C plugin. So we had the add plugin, we put the subtract plugin next to it. Now I just run my code. Value 1, we can say 10. Value 2 is 5. Now as you see, we have two options. We don't have one option because we dropped one plugin into the plugin folder. So this time I say subtract, it says the result is 5. So as you see, it's very useful and it's very easy to use reflection in order to make your system extendable. So without having to change your code, you just create plugins, drop it into a folder, and it loads it. So for example, if you have a system and you want to add menus to it dynamically, you can just do the same thing. Create an interface that defines your menu and functionalities that are attached to menu items. Drop it in a folder, load it, and then you can populate menus and things like that. It's very useful. I hope that you enjoyed going through this course and you learned something from it. Feel free to ask any questions that you might have.